have 2
I have a lot
sine
of
squared of 2x minus sine of 2x equals 1.
You gotta take out the GCF first, right? Or do we bring that one over?
Okay, so first thing, make sure that the angles match in your trig functions. So if one of those were a sine x and one of them were a sine 2x, then we would need to use a double angle formula. Now they're both 2x, so we could use a double angle formula, but I wouldn't recommend it because if I have to change both of those, my problem is going to get a lot more complicated and probably not help me out. So the way we were doing them Friday is when we saw a 2x, and if I'm not doing a double angle to get rid of it, we just made a note to ourselves that that meant what?
2 solutions.
Double the solutions.
Or double, yeah.
That means between 0 and 360, that 2x would cause our graph to have 2 complete cycles. So we have to get the answers for both of those. I am in degrees because I said over 0 to 360. So we have 2 sine squared 2x minus sine 2x. If we subtract over our 1, that equals 0. Okay, so it's equal to 0, but now we don't have a greatest common factor, so what would we do?
Slip and slide.
So now we have to factor this. So we need two numbers that multiply to -2 and add to -1.
-2 probably.
Negative.
You can't have 2 negatives because you're multiplying. And then divide by the 2.
Okay. Set these equal to 0.
You have to divide it.
Oh yeah, thank you. I was going to do it after here, but we usually do sooner. Alright, so that means sine of 2x is equal to 1. Or -1. Alright. So when is sine equal to positive 1?
90.
That's like on your inner circle when the y is 1, so that's 90 degrees. Okay, sine is negative in quadrants 3 and 4. Reference angle, when is sine 1/2?
30 degrees.
So 30 degrees in quadrant 3, so 180 plus 30 is 210. In quadrant 4, 360 minus 30. Okay. And if I remember correctly, we went ahead and got our double solutions now, right? That's the way we decided to do it. So we know we got 3 solutions. So if I'm getting double solutions, we have 3 more. And we get those just by adding 360 to the answers we already have. So 90 plus 360, 210 plus 360,
570.
and 330 plus 360. And then to get x, what do I have to do to all of those?
Divide by 2.
you'll know if you did too many solutions because it will be bigger than 360. So you notice 345 is the closest we can get. So we are done. If I said all solutions, what would we have to do?
Plus 360.
360K.
Is it though?
Isn't it?
Well, okay. This is where it starts to get
Plus
confusing.
60.
So there are multiple ways you could write your final answer that are equivalent. One option is to do all 6 of these plus 360K. It's not the most concise, but it does give us all of our answers. The other way is to take the original ones. So these would have been my 3 original, right? Normal period, we would have added 360. So when you divide that by 2, what do you get? 180. So you could write each of these plus 180K. Where K is an integer. Notice if you had done like 45 plus 180 is the 225. 105 plus 180 does give me the 285. So the other option, you can do all 6 plus 360K or just the original ones plus your period.
Couldn't we just do 45 plus degrees plus 60? Or does it have, because.
Let's see. So it would end up giving us some that didn't work later on, I think. Okay. So what would you do first to solve this one? Okay, we may not know off the top of our head when cosecant is equal to 2, but we have to get rid of the square, so what would we do first? Square root. If you add a square root, you have to do plus and minus with it, so that's going to put us in every quadrant. So cosecant of x over 2 is equal to plus or minus the square root of 2. So that means the reciprocal of cosecant, sine, would be 1 over that, or square root of 2 over 2. Quadrants. When is sine positive or negative? All of them. So we really don't even need that. We know we're going to have every quadrant. Reference angle.
45.
So our angle, x over 2, could equal 45 in quadrant 1 is 45. In quadrant 2, 135. Quadrant 3, 225. Quadrant 4, 315. And like we talked about, if it helps you to use a unit circle, that's fine as long as you can fill it out.
So x being over 2, does that change the amount of
Yes. So let me show you in 1 second. If you're solving for x, what would you do now?
Multiply by 2.
Okay, so if I take every single answer times 2. 45 times 2 is 90. 135 times 2, 270.
It's not have the 2 right?
So, my questions. The first question said for every answer between 0 and 360. What happened here?
You got 2 there, 2 there.
2 of these angles don't fit in my interval. So that's what happens if your angle is like over 2 or over 3 or something. You might have extra answers. So when I only want the ones between 0 and 360, I can only use the 90 and the 270. Now the second one, when it says all possible, we can do each of these plus the period. What is our period?
720.
You can either get it from the beginning, or you could think, well, if I wanted all possible, I would add 360 to this. And so when you multiply by 2, the 360 becomes 720.
You do plus 180 to the 90 degrees.
Yes, there are more concise options. If you use 90 plus 180, it gives you the 270. So there are lots of different variations that will work. You just have to give me an equivalent one.
My integer sign is just getting more and more like a double letter Z.
Questions on that one? Okay. Let's keep practicing. These can be a little bit confusing. Let's do.
The radical is just over the 3 right now, the cosine is 1.
Correct. So we'll probably try 2 more, this one and 1 more, and then I'll give you guys time to work. We're trying to get cosine by itself. We'll divide by the 2 radical 3. Do I have double or triple solutions on this one? Anything like that?
No.
No, I have to watch and make sure all my answers work at the end. So if I cosine of x over 2. Alright, we can't leave the radical on the bottom. So if you multiply it on top, that's 3 radical 3 over 6, or quadrants. When is cosine positive? Reference angle. We are back in radians. When is cosine radical 3 over 2?
Pi over 6.
So my angle, x over 2, could equal, in quadrant 1, our reference angle is our angle. In quadrant 4, double minus 1, or if you're looking at your circle, 11 pi over 6. Yes, if I want to get x by itself, we take these times 2. So 2 pi over 6 would be pi over 3. 22 pi over 6 would be 11 pi over.
Get that bad boy out of here.
Okay. My directions were to get every answer between 0 and 2 pi. So pi over 3 is definitely between 0 and 2 pi. 11 divided by 3, though, is bigger than 2. So that one is not in my interval. So I didn't ask for all possible here. The only one you have to give me is the pi over 3. But I wrote pi over 2 for some reason.
Look how big he made your box.
I know.
He's got a lot of room.
Just trying to
He's
fool
a
you.
big house.
Alright. Is that okay?
Sorry, I got scared.
Dramatic.
It's not.
Can we subtract?
Oh, yeah.
Alright, so we need to get the tangents together.
Hey, that's a lot of angles that I don't really like.
So what would you do first?
Add the 2 over, the 2 tangent.
So we get 7 tangent to theta equals 3. So we're trying to get the tangent by itself. The fact that it's a 2 theta tells me what?
Double answers. I wanted to say double angle for some reason.
Well, it is a
It
double
is,
angle.
but that's not what
And you could use the double angle formula if you preferred, but it's not going to be pretty.
why would I want?
Okay. When is tangent positive?
1, 2.
1
No, yep, 3. Okay, yeah.
and 3. Reference angle. Do we know when tangent is 3/7?
No.
We do not. So what do we do?
Put it in the calculator.
Okay.
Degrees.
Make sure you are in degree mode.
It's not tangent inverse, right? It's
It
just,
is tangent inverse. If you're looking for the angle, you do the inverse.
That's right. I knew that. Sure, that's a 9 and that G.
How do we plug this in?
Tangent inverse. All right. So in quadrant 1, my reference angle is my angle. How would I put that in quadrant 3?
I add 180.
So 180 plus that.
2, 3,
Am I done?
Yeah, double.
Double solution, so we know we have 2 more. How do we get those?
Add 360.
So that's what 2 theta equals. So then to get theta, we do
Divide it by 2.
every one of those divided by 2. That's a lot of decimals. Let's just go to 1 decimal place.
Awesome. Awesome.
Okay, so today's assignment is a handout that I'm getting ready to give you. Then we are going to start reviewing. So we're going to do, I don't know if you can really call it a test because it's only 3 sections. So something in between a quiz and a test.
Quest.
A quest. We're going to take a quest
We're going
over
on a
chapter
quest.
6. Okay, because it's not as much material. But we will do review Tuesday and Wednesday. So Tuesday will probably be like a work day for a study guide. Wednesday we'll discuss it. So if you're going Wednesday, you want to watch that video and make sure you're ready. Thursday we will do our quest. And then Friday I will. Is anybody on Friday? I don't even know what events are going
No,
on.
I don't think
nothing's
so.
on Friday. There's
Nothing's
stuff on
Friday.
Thursday.
Oh, yeah.
And I don't know. I haven't seen any rosters for that yet. So I'm going